the probability that we know that most of the time we talk about the sample space. We talk about the sample space. And we talk about events. And how do we get the probability of an event? The probability of an event is calculated by the number of those events divided by the total number of that events, the sample space. That is how we get the probability of a certain event. But now we also need to remember that probability lies between 0 and 1. Lies between 0 and 1. If you are requested to calculate the probability and you get the probability of A is equals to 7, just know that whatever you did there is wrong. Very wrong. Why? Probability can never be greater than 1. Probability can never be less than 0. Probability can never be more than 1. Probability cannot be 0. But what if your probability is 1? What if your probability is 1? What do we say? We say if your probability of that event is equals to 1, that one is called a sure event. We are 100% sure that that event will occur. What if the probability of that event that we're talking about is 0? Then we say it's a rare event. Rare event. It means even if it can happen, it happens once after billions of years or billions of trials. So it's a rare event. That is what we say. But what if the probability of that event is 1 over 2, half? Then we say the probability is equally likely. For example, if a lady is pregnant and the lady must give birth, these days it's just that technology is there and people can go and check on that scanner thing to check if it's a boy or it's a girl. But if there was no such, the probability of giving birth to a boy or a girl will be 0.5, 50-50 chance. That's why that's the language we usually use, 50-50 chance. So it's possible that this lady can give birth to a boy, or this lady can give birth to a girl, either a boy or a girl. So the chances are equal in that case. Now, if we remember very well, we went on and talk about the mutually exclusive and mutually inclusive. That is when the Venn diagram was introduced to us. Can I talk about Venn diagram? Venn diagram. Am I still audible to everyone? Say yes if I'm still audible.
Yes, sir.
Okay, thank you. Stop me at any point to ask me a question if you feel like you need to ask a question, so that I can know. Mind you guys, this is a summary of whatever that we did in the previous grades. So I'm just trying to summarize and remind you of what you already know. Venn diagram. Our Venn diagrams, we've got this kind of a Venn diagram. In grade 10, when they were introducing the Venn diagrams to us. And then they also said there is this kind of a Venn diagram. Let's say we've got event A there, and then we've got event B there. The same happens here. We've got event A, and then we've got event B. And the sample space is a certain number there. That's our sample space. Now, between mutually exclusive and mutually inclusive, which one is the first one? Which one is the second one? Mutually exclusive, mutually inclusive. Which one is the first one? Which one is the second one?
I think the first one is inclusive, sir.
Okay, the first one is mutually inclusive. That it has the intersection mutually inclusive. How do we know that? There is an intersection, and the intersection, we say it is called the probability of event A and event B. That is the intersection, and that intersection is not zero. For as long as the intersection is not zero, we know that it's mutually inclusive. Meaning, if in this case there is no intersection, it means it is mutually exclusive. But for mutually exclusive, we know that the probability of A and B, the intersection, will always be zero. If the S asks you, are the events mutually exclusive? Check. I wrote something wrong here. Check the probability of A and B, event A and event B. If the event A, probability of event A and event B is zero, then you know that they are mutually exclusive. If the probability of event A and event B is not zero, we know they are mutually inclusive. Going forward, there is a formula that you learned. If I'm not wrong, you learned it in grade 10 also. The formula says the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. I did check the information sheet today. I realized that that formula is there on the information sheet. This formula is there on the phone. I was not very aware that it is there, but I was just checking for out of curiosity. I realized that that formula is there. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now, moving from there, I'm just reminding you of these things. Let's go to complementary events. Complementary events. If I'm saying to you the probability that this lady that we were talking about will give birth to a girl, it's 0.3. What is the probability that this lady that we're talking about will give birth to a boy? The state 0, thank you, 0.7. Now, that is where the story about complementary events comes in. We're saying the probability of a boy will be equals to 0.7. Now the question, someone will be like, but how did I come to that? Remember, complementary events, we've got the probability of A plus the probability of not A. I can write the word not there, but I can still write that. Probability of A plus the probability of not A, they must give me 1. So if we say this person is a boy, it means not boy is a girl. If we say this person is a girl, it means not girl is a boy. So I'm saying in that case we talk about complementary events. Complementary events. We say, if I give the example of the one that we're just talking about now, if we talk about that one, and I'm saying what is the probability of, okay, let me just leave that as it is and say probability of A. What is the probability that this person will give birth to a girl plus the probability that this person will not give birth to a girl must give me -1. I know the probability of a girl is 0,3 plus the probability of not girl. Obviously, in our normal way of thinking, we know that not girl means boy is equals to 1. Then we transpose the probability of not girl, that means we're talking about boy, will be 1 minus 0,3, meaning the probability of this boy, the not girl, will be equals to 0,7. I was helping someone on how did we come to 0,7. Okay, let me go back a little bit. I'm saying with probability we talk about events and sample space, and for you to calculate the probability of an event, like for example, the probability of finding boy in a certain class, so is the number of boys divided by the total number of learners in the class. Number of boys, maybe I've got 70 learners in the class and then 25 are boys. So if I want the probability of the event boy, I'm going to say 25 divided by 70. If you check the under, and the number is not 0, is not less than 0, is not greater than 1, the number that you're going to get there. That is how we calculate probability. And again, guys, I know I'm going to ask you a lot of questions. I'm just trying to remind you. I'm just taking you through the basics that every one of you should remember. And again, the probability, like I just said, must never be less than 0, mean must never be negative. And your probability must never be less than 1. If by any chance there's a possibility that they ask you about probability where it's 1, you know that that is a sure event. If by any chance you get the probability is 0, that is a rare event, something that can never happen. But if the probability can be half, I made a very clear example to say if the probability is half. I gave an example with a lady to say the lady is pregnant. Okay, or let's talk about a coin. A coin. A coin has got the head side and the tail side. I don't know why they say tail, but you guys know about that, head and tail. The probability of head getting a head or a tail, it's equal, because immediately you spin the coin, when it comes back and land, it cannot land on both sides. It can only land at one side. So the probability of getting the head or the tail is 1/2, equally likely for head and tail. I'm saying you also learned about the Venn diagrams, and your Venn diagrams were explained too, with a Venn diagram that is saying mutually exclusive and the one that is saying mutually inclusive. And if you remember very well, your teacher said mutually inclusive means the probability of A and B, the intersection is there, mutually inclusive. That is why I'm saying the probability of A and B is not 0, because there is an intersection. But for mutually exclusive, there is no intersection. For example, if I can say, I want to go to Soweto, but at that same time, I also want to be in Pretoria. You guys know very well that Those two events can never happen at the same time. I can't be in Soweto and be in Pretoria at the same time. So there won't be any intersection there. That is why I'm saying the intersection probability of A and B is 0 for mutually exclusive. And I'm saying, as I repeated myself, I'm saying this formula is given to you on the formula sheet. Probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. And lastly, I gave an example about complementary events. Complementary events. It means the probability of A plus the probability of not A. They must give you -1. And I gave an example about the probability of a girl giving birth to a girl. It's 0.3. Automatically, you know that the probability of giving birth to a boy, meaning not girl, should be 0.7. Grade 11, you were taught about the independent events. Anyone who remembers something about the independent events? Talk to me. Independent events. Then from there we can start answering the questions. Independent events. Anyone who remembers? Am I still audible to everyone? Someone say yes if I'm still there. Can you still hear me?
Yes.
Okay, thank you. Now, independent events. Independent events. The independent events. Okay, someone wanted to talk?
Independent events basically means when the outcome of one event does not affect the outcome of another event.
Yes, thank you. Yes, but there's a certain formula that was used for that. Do you remember it? Not sure? Okay, still thinking?
No, sir.
Okay, thank you for that. The independent events, there is this formula. The probability of A and B is equals to the probability of A multiplied by the probability of B. They are going to ask you, they love to ask this one, are the events independent or not? So you need to check, is the probability of A and B the same as probability of A multiplied by B? If the two are the same, let's say you were given that the probability of A and B is 0.2, and you take the probability of A and you multiply it with the probability of B, you also get 0.2. Then your conclusion is that the two events are independent. The two events are independent. Now, there was something that I wanted to say, but I forgot. Okay, but it's gonna come, no problem. It's gonna come, whatever that I'm thinking. Let's start here. Oh yeah, it's coming. Thank you for that. It's coming. From here, the questions that we must expect in the test, that is the Venn diagram. Let me use it. The questions that are here that we are going to do now, and also questions related to the Venn diagram, questions related to the tree diagrams, questions related to the contingency tables. And most of all these things, they happen to include independent events, especially the contingency table. They like to ask about independent events on the contingency tables. So for your revision, everyone who's going to do revision with me, they know that we are going to do all this. But if you know that soon you are not going to be with me, this is what you must go and revise. Venn diagrams, especially the, this ones, 3. No, not those 2. Those 2, yes, but it's just a bonus. But these ones that are moving as 3 like that. And then the tree diagrams and the contingency tables. I'm just reminding you of what to remember. Now that I finished summarizing, can we start with the real thing? Exam question papers. There's a question here. A question here, it is saying, given the following probabilities, determine whether or not event A and event B are mutually exclusive. Event A and event B are mutually exclusive. How are we going to do that?
I'm not sure if I'm right, but I think we use the formula that you showed us when we're given the mutual exclusive. What?
Are you referring to this formula? Probability of A or B is equals to probability of A plus probability of B minus the probability of A and B. Are you referring to this one, or you're referring to the other one? Vida, I believe that was you talking.
I wasn't referring to that.
Okay. Which one were you referring to?
The other one you said is equals to 0.
Probability of A and B is equals to 0.
Yeah.
Okay. But how are we going to find the probability of A and B?
We say the probability of A. You have to find the probability of B.
Okay. I want to understand what you are saying. You are saying I must say the probability of A multiplied by the probability of B. That's what you are saying. Am I hearing that correctly? Okay. Am I told that, remember, I'm not trying to interrogate you, I'm trying to direct you. Am I told that the events are independent? No, I'm not told. So I use this if I want to check if the events are independent. Oh, I made a mistake here when I was writing. Sorry guys, I was supposed to write or here. Let's use the same formula, by the way, and check. Let's use the same formula and check. Or maybe we can draw a Venn diagram. But now our Venn diagram might confuse us at some point. Let's try to check. Oh, the next question is saying hence. But now I'm not sure what the hence is gonna work out the way I want. We know the probability of A or B. It's 0,6. What must happen for the events to be mutually exclusive? Anyone?
No problem.
Okay, I think I'll have to check who's talking so that I can be sure. What must happen for the events to be mutually exclusive?
They must be equal to 0.
The probability of A and B must be equals to 0. Probability of A and B must be equals to 0. Let's check if the probability of A and B is 0. Okay, so we've got a probability of A, it's 0,4 plus probability of B it's 0,2. If I'm making a mistake, please guys tell me. And then the probability of A and B, that is what we're looking for. We can transpose, then we're going to have the probability of A and B is equals to what is 0,4 plus 0,2?
0,6.
0,6. Remember guys, I brought this one this side, then I added here, I got 0,6, so I must bring this one to the other side. Then am I right if I'm going to say it's going to say minus 0,6? Am I right if I'm saying that?
Yes, sir.
Okay, so yeah, you guys can transpose the way you know. There's someone who's asking a question. Okay, now we've got the probability of A and B, which is equals to how much?
0.
0. Let's answer the question.
0. 0.
Yes, let's answer the question. Are the events mutually exclusive or they are not?
They are mutually exclusive.
They are. Therefore, event A and B are mutually exclusive. And my reason is that the probability of A and B is equals to 0. They are saying hence determine the probability of A and B. And we did that. We found that it's 0. We did that. Do we have a question before we can move on to the next question? Please ask if you feel like you need to ask. Okay, since there's no question, let's move on. Next question. Here is the next question here. Still saying the same story, by the way. Should we do it? Yeah, let's just do it. It's saying the probability of A is 0,2, the probability of B is 0,35, and the probability of A or B is 0,55. Explain whether A and B are mutually exclusive events. Show all your calculations. So we do remember that for mutually exclusive, we must get the probability of A and B to be equals to 0. That's what we want. If it's not 0, then it's not mutually exclusive. Now let's try. If we try that, we use the same formula which I said is there on the information sheet. The probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. Please watch out guys, in case I'm writing and I made a mistake, notify me. What do I put in space of the probability of A and or B? What do I put in space of this part?
0,5.
0,55 equals to. In space of the probability of A, what must I put? 0,2. Before we continue, what if here, just what if here they gave you the probability, okay, let me write it this side, probability of not B is equals to 0,65. How were you going to get the probability of B? Because I know next time it might happen something like that. They give you something like that. They say the probability of not B is 0,65. But now this is not B, this is B. So how am I going to get the probability of B while I'm given the probability of not B?
Maybe say you're going to take one and subtract 0,65.
Yes.
And get the
Use,
for B.
thank you. Use the complementary events. 1 minus 0,65. That is how we are going to do it. 1 minus 0,65, and then you use the complementary events. Then the answer would be 0.35 minus the probability of A and B. Guys, I said if I'm making a mistake, you have to tell me. You didn't tell me the mistake I made here. I wrote N instead of and B. Now let's transpose. This one comes this side and then this one comes this side. Let's do that and check on how we work out. But it's up to you guys. You know how you transpose. Don't try to force to do my way. Okay, so if we do like that, we've got the probability of A and B, which is equals to 0. What is 0.2 plus 0.35?
0.55.
0.55. And transpose 0.5 is going to be, 0.55 is going to be minus 0.55. And now we've got the probability of A and B being equals to how much?
0.
0. Then what is your conclusion here?
The events of A and B are mutually exclusive.
Event A and B are mutually exclusive because they are giving the probability of A and B equals to 0. Event A, therefore event A and B are mutually exclusive. Any questions if you guys have? No questions. Okay. Wow. I did put independent events here. But where is that question? I wanted us to start with this question of the independent events. Okay. Then we can follow with other questions. Let's try and start with this question for independent events. Then when we do contingency tables, we also need to remember the independent events. They like to mix up the contingency tables with the independent events. Wow, my space is not spacing now. Sorry for that, guys. Now that is not doing what I want. I'm just going to leave it here. I'll work it out later. Let me just move it there. Let's talk about this question. In this question, you are given the probability of A and you're given the probability of B. You're also given the probability of A or B. Equation 80. Determine whether A and B are independent events or not. Please don't say they are dependent events. Just say they are independent or you say they are not independent. Okay. Now, remember what I said about independent events. What did I say about independent events? Anyone who remembers?
The event where the outcome is not dependent on the outcome of the second one.
Yes, and yes, and what about the formula? What did I say?
So I said that we said P into A and B equals to PA times P is to B.
The probability of A and B is equals to the probability of A multiplied by the probability of B. Independent. Hey, so guys, yo, independent events. If I did not write the what you know, just know that is what I was writing. I was writing what you know. Guys, immediately the question asks you about independent events. This thing must automatically click in your head. Immediately you see that. Independent events. This thing must automatically click in your head. You are forced to check if the probability of A and B is the same as the probability of A multiplied by the probability of B for the independent events. Now, if you can remind me here, what must I do? They're saying show the calculations you used to get the answer. Anyone? Where do I start? What do I do? Remember, guys, your answers are not right. They are also not wrong. Yes?
Oh my God. That long formula, probability of A or B is equals to probability of A plus probability of B
Probability
minus
of
probability
A
of
or
and
B is equals to the probability of A plus the probability of B minus the probability of A and B. So I have to substitute here.
Yeah.
What do I put in space of the probability of A or B?
0.4
0.428 equals to. What do I put in space of the probability of A?
0.12.
0.12. Meaning in the probability of B, I'm going to put 0.35.
Yes.
Okay, 0.35 minus the probability of A and B. So basically you are saying we must look for the probability of A and B. Let's transpose. The probability of A and B will be equals to, can you please guys tell me the numbers? What do I write? Equals to what? I hope people are pressing the calculators and I'm waiting for the numbers. You are forcing me to use my own now because you don't want to talk to me.
0.47, sir.
0.47. 0.47. And then we transpose this one. Transpose, then it's going to be minus 0.428. What answer do we get?
0.042.
0,
0.42.
042. I'm gonna pause and wait for a question. I'm gonna pause and wait for a question so that whoever is saying I feel like I'm missing out, then you tell me where are you missing out so that I can be sure. My people are not asking questions to save time. Let's continue. We are done. We found the probability of A and B. What do we do from here?
Since we have the probability of A and B, we're going to use the formula that you told us to use for independent what. That one is the blue highlight.
She's saying independent what. No problem. Independent what. Okay. The probability of A, and then we multiply it with the probability of B. What do we put in place of the probability of A? 0.12. Multiply with 0.35. What answer do we get?
0.042.
0.042. What is your conclusion?
Therefore, probability of A and B are independent.
Event.
Because they're equal.
Event. Use the word event. Therefore, event A and event B are independent. Why are they independent? Because the probability of A and B is equals to the probability of A multiplied by the probability of B, which is the same also as 0,042. Wow, I covered a lot, ne? I covered a lot up to this point. Questions? No questions? Since there are no questions, let's go back. We spoke about independent events. We spoke about mutually exclusive events. So basically, we're trying to cover both grade 10 and grade 11. Now, this is one of the questions you might get in the exam. And we want those 8 marks. As you are reading here, I just want to double check if everyone is still there and still listening. And even the minutes now, each the time is moving. Vaida, I heard her voice. Nelly said I heard her. Chabalala and Orienda. Ndokoz, are you there?
Yes, sir.
Okay. Nokwanda, are you there?
Yes, sir.
Mhlongo, are you there?
Yes, sir.
Okay. Noktula, are you there?
Yes.
Okay, thank you. I just wanted to check if I'm not just left with 2 or 1 person. Guys, the time is not allowing us, but can we try to draw the Venn diagram very fast? It is saying here 270 grade 11 learners were asked if they take mathematics, M, physical science, P, or accounting. So we know that we are going to have mathematics, we are going to have physical science, and we're also going to have accounting. Mathematics, physical science, and accounting. And when we add all these numbers inside this box, when we add all those numbers, the sample space, they must give us 270. So they are saying 118 said they take mathematics. Where do I put 118? I'm asking that intentionally to confuse you. Okay, to avoid to waste time, guys. Let me not confuse you. Okay. You always, always make sure that you start with the number that is at the center. The one that is saying all and the one that is saying none, put outside. The one that's saying all. So read as you read. Here they're saying 30. Take all the 3 subjects. So 30 must be in the center there. 30 must be in the center there. Okay, I'm going to change the thickness of the pen. Then I'll put 30 there so that I can be able to see. 30 there. Now, from here, we can go to where they are saying end. We are going to where they are saying end. Now, we are done with this one. Done. Okay, so let's go and check. They are saying 45 take mathematics and accounting. 45 take mathematics and accounting. Where is mathematics and accounting? Then I go to where mathematics and accounting meet. Where do they meet? Mathematics and accounting, they meet here. That is where they meet. But where they meet, I must have how much? 45. But out of the 45, I already have got 30. I already have got 30. That's why we always start at the center. So what must I put in this remaining space? How much must I put here? Guys, let's save time. Okay? Yeah, let's try to save time.
15, sir.
15. Thank you. Now, let's move on to the next one. We're done with end. We're moving on to the next one. The other end. It's saying 55 take physical science and accounting. Then we go to where physical science and accounting meet. Physical science and accounting, they meet there. That is where physical science and accounting meet. What do I write on the other space?
25.
25. Okay, 25. And they are saying 250 take at least one subject. But maybe that one might confuse us. Let's try to fill up as we go on. I will come back to this one. So we are done. Let me highlight the ones that we're done with. How many minutes are we remaining with?
9 minutes.
Okay, we are done here. So the easy one would be accounting now, because accounting is filled up with 15, 30, and 25. So I want the whole circle of accounting. That is the whole circle that I want. How much is this whole circle of accounting? They said the circle of accounting is 90. So what must I write on the remaining space on the accounting?
20.
How did you get 20?
It's a ulo 90 lo minus 30 minus 15 spin is minus 25.
Okay, and then you got how much?
20.
20. 20. So now we are done with this part. We're done with that part. Okay. Now, we are left with 118 said they take mathematics, 160 they take physical sciences, and then 250 take at least one of the subjects. So how am I going to fill up the mathematics and the physical science? I feel like I'm missing something here. I'm not sure if I'm missing something or what. Is it me, or maybe I'm having the problem here? Can someone?
So,
Yes.
we going to minus 30 and 15 go 118.
We're going to minus what?
30 and 15.
Go 118.
If I'm not mistaken, it's Uncle Paul.
I want to agree and I also want to disagree. But you are saying we are going to focus on this one. This one has got 2 empty spaces. We are aware of that, ne?
Yes, sir.
Okay. So, okay, let's come back here. Let's come back here. I agree with you, my girl, ne? But we're going to have a problem because let me use a red pen. We've got this one and this one. So we're going to have a problem. Can you see that?
Yes, sir.
Yeah, we're going to have a problem there. So now, let's come to this one. My pen is on strike and I don't have time. Let's come to this one. What does this mean?
I think it means that the students that are taking each subject, like there are 250, so they are giving us the clue of the number of learners that they are not taking those subjects.
Okay. At least one. It means greater or equal to 1. Greater than 1 or equal to 1. So we want that part of at least, greater or equals to. When they say at most, they mean less or equals to. Remember that. So let's use that. At least 1. At least 1. They're not saying none. They're saying at least 1. So we're going to take 250 and subtract 20 and subtract 25 and subtract 250 subtract 15 subtract 20 subtract 25. How much do we get? I feel like I'm also missing something.
19.
How much?
Sir, can I ask you a question, sir?
Yes, please.
Sir, do we say 250 minus 30 minus 25 minus 15?
Minus, can we leave 20 for now? I'm still thinking. I messed up my own thinking now. Can we leave 20 for now? Let's say minus 15 minus 30 minus 25. How much do we get?
180.
180.
180.
Yebo.
Yes, sir.
Okay. And again, if we use that and subtract 20, how much do we get?
60.
Hello?
160, sir.
160.
160. Okay. That's not gonna work out. I'm gonna put X here. But let's let's try to work it out first before. I'm gonna put X there. 160. 160. Can you add all these numbers for now? Let me I just want to double check something there. Sorry for that. I just want to double check something. I don't know also the time that I'm left with. My problem is I can't think straight because of the time now. How many minutes?
So the answer is, sir,
Yes.
3 minutes left, sir.
How much? How many?
Put X and then we say, and we're given the numbers of the learners that are taking math, but they didn't say only. So we minus the 50 and the 30 and the X.
Okay, we'll come there, Vida. Can we talk about the time? How many minutes are we remaining with? I want to think straight.
2 minutes.
2. Guys, we can't finish this in 2 minutes. Like now, Vida, you were saying something?
I was saying, since we're told we have 118 learners who are taking maths, but they didn't say only. So we're going to say 150 minus 80 minus the X to find our N.
Yes. But now that's why I was saying let's write X there because we don't know that value. And then how are we going to get that? We're going to use 250. We'll wrap up tomorrow, guys, because of time. That's why I was saying let's use X there. Then you guys will finish it up. I'm leaving it there. You'll finish it up. We'll wrap it up tomorrow. You know that I can't finish this because of time. I was going to finish it. Saying I've got less than 1 minute. So can you finish it in your own space? And then tomorrow we can finish up that question. Thank you for your time. Keep on working hard. Good night. Bye-bye. Thank you. Bye-bye, guys. Let's log out. And it's gonna log everyone out. Okay. Yeah. Like I said, we'll finish that one up tomorrow. Since because of time is not allowing us. Whoever is doing this, just make sure that you double check and then finish it up at your own time. Then maybe you can join us tomorrow to finish it up. Otherwise, we'll finish it together with the other learners tomorrow. Thank you.